Hello class, just wanted to review your assignments for today and what we're going to be talking about. Um, you have some review questions here for numbers 1 and 2. These are review, so I'm not going to do them in this video. I just want to point something out for here for number 1 and 2. You're finding the vertex and the axis of symmetry. Okay, so remember your axis of symmetry is that imaginary line, right, that cuts that parabola in half. So it's always going to be x equals something, depending where it is on the x-axis, okay? So make sure you're looking out for that. In fact, why don't we, I think it's probably better. Let's just go ahead and do one together here. So let's look at number 1. We have the function f of x equals 2x squared plus 8x. Remember, f of x is the same as y. So I'm just going to list my a value, my b value, and my c value. My a value is 2. B value is 8, and you can see there is no C value, so I'm going to write 0. So we're going to find the vertex using our vertex formula, negative b over 2a, so I'm going to plug in b and a. So when I plug in 8, it becomes negative 8 over 2 times a, so that's 2 times 2, which is 4. So negative 8 divided by 4 is negative 2. That's the x value of my vertex, and then I'm going to plug that back in for x right here to find my y value, negative 2, just like that. All right, so negative 2 squared is 4 right here. Then 4 times 2 is 8. And then 8 times negative 2 here is negative 16. And 8 minus 16 is negative 8. So the y value of the vertex is negative 8, which makes my vertex negative 2, negative 8. Which means my axis of symmetry, that's the AOS. So watch, you don't have to do this, but I'm going to draw like just a graph. So negative 2, negative 8 would be like somewhere down here, right? So it doesn't really matter if the vertex is going up or if the parabola is going up or down. You're going to have the same axis of symmetry no matter what. So that axis of symmetry is going to be at negative 2 on the x-axis because that's the coordinates of the vertex, negative 2, negative 8, right? So my axis of symmetry is going to be x equals negative 2. And you'll notice it's always just the x-coordinate of the vertex, right? All right, so let's erase that. Try out number 2 on your own. Just be careful with number 2. It looks like you have a missing term. Figure out if it's A, B, or C, right? So make sure you're plugging those values in carefully. Let's jump down to number 5 here. So number 5 says, it says in the questions below, find the value of the unknown variable. Okay, so it says for the equation y equals ax squared plus ac, find the value of a when x is 3, y is 1, and c is negative 2. So we're going to plug those values in. All right, so they said y is 1, so I'm going to substitute that in. So 1 equals, they said find the value of a, so I'm not going to substitute anything there. So I'm going to write a times, and then x is 3 squared, and then plus, and then c is negative 2. So see, I'm just substituting that information in, and now I'm going to solve for a. So let's clean this up a little bit. So 1 equals, I can see right here that 3 squared is 9. Always square before you multiply. 3 squared is 9, and then 9 times a is just 9a. So I can write it like that. And then plus negative 2 is minus 2, right? Now I'm going to solve for a, so I want to add 2 to both sides. So that gives me 3 equals 9a. And then I'm going to divide by 9 on both sides. And 3 divided by 9 is not 3, you guys. 9 divided by 3 is 3. 3 divided by 9 is 1/3. Okay, 1/3, because you can divide both those by 3, right? That's 1/3. So you would write a equals 1/3. And that's what you're doing there for those questions, okay? I really want you guys to read over these notes right here, okay? I mean, make sure you keep this page. You should write these into your notes, okay, for 2.4. So make notes that are 2.4, okay, and just use the same title, and then I want you to copy this information into your notes, all right, because today we're talking about solving for the a term. Let's go to the back side of the worksheet here and let's do number 7. So you can see we have a quadratic function in vertex form, which is right here, y equals a times x minus a squared plus k. And we're getting some values here. So it says we're solving for a, so they're saying x is 3, y is -4, h is 2, and k is 0. So let's plug in all those values for those variables and solve for a. Okay, so let's see, y, so there goes y, 3 is going to go in for x, 2 for h, and 0 for k. So, -4 goes in for y equals a, solving for a, times 3 goes in for x, minus 2 for h squared, and then plus 0 for k. All right, let's clean this up a little bit. So we're going to do this parentheses first. So 3 minus 2 is 1, and then 1 squared, right? 3 minus 2 is 1. 1 squared is 1. And then 1 times a is just 1a. So that gives me -4 equals 1a, and then plus 0. So 0 is nothing. I don't really even need that. So look, I have 1a equals -4, or a equals -4. So there's nothing else that I need to do. So I found my a value. When we're given the vertex h and k and another point that's on the graph, x and y, we can figure out what that a value is. So therefore, the function is y equals, my a term is -4 times x minus h was 2 because they told us squared, and then 0 is k. So I can put plus 0 on here at the end, but it's not necessary because it's 0, so I can just leave it off. So that's the equation of my function. All right, we're finding the a value. You need the a value, your h, and your k to write an equation. Notice how y and x are always in the equation. We just substituted the point up here, 3, -4, into the equation for x and y so that we could find a. But once we find a and we know our vertex h and k, we don't need our y and x are always going to be in our equation. So let's try another one. Let's go do number 12 here. I'll make this the last one. So we have the vertex already right here. H and k, that's your vertex. 4, 1 is the vertex, right? So that's what we're going to plug into our equation. Now the only thing we need to find is the a value, okay? They don't tell us the a value. So we can find the a value by plugging in another point that's on the graph. In this case, they tell us 0, -5 is on the graph. So we're going to plug that in for x and y, right? And we're going to plug h and k in because they told us that's our vertex. And then notice how the only variable left is a. So -5 substituted for y equals a times 0 substituted for x minus 4 for h squared, and then plus -5 for k. Remember, plus -5 is the same as -5. You could write -5 as well. Okay, so let's solve for a. Let's clean this up a little bit. So we have -5 equals, let's do this, 0 minus 4, that's -4, right? And then -4 squared is positive 16, and then you multiply it by a. So 16 times a is 16a. So just to recap, 0 minus 4, -4, and then I squared it, that's 16, and then I multiply it by a, 16a. Plus -5 is -5, so I'm going to write -5. Now let's solve for a. So let's add 5 to both sides there. So -5 plus 5 is 0 equals 16a. And then we divide both sides by 16 there. And look at that. A equals 0. A equals 0. 0 divided by 16 is 0. So our function is, let's look here, sorry. Oops. Back in. I'm going to go over here because I just need some more space. So I'm going to write y equals 0 for a times x minus, and then my h and my k. So 4 was h squared, and then plus 1. Well, here's what happens. Okay, x minus 4 squared, and then anything times 0 just wipes it out. And what are we left with? Y equals 1. That's our equation. So for this one, I'm going to write y equals 1. All right, and that's what I want you to do for the rest of these problems over here. You're solving for the a term. Your final equation, here is a vertex form, y equals a times x minus h squared plus k. Your final equation, you should have values in there for h and k and a. Your a term and your h and your k, which is your vertex. Your equation should always have, your final function equation should always have y and should always have x in it. All right? In the beginning, you substitute values in for y and x that are a part of the graph so that you can solve for a, but your final function should always have y and x in it. Okay? All right, do a good job on the rest of those problems. Please let me know if you need help on any of the rest of those, and I'd be happy to help you.